Now that we've worked with our properties for exponents, we're now ready to turn our attention to the problem of what happens when the exponent's a negative. And what does that mean? You might recall from earlier that we had this problem, g to the 6th over g to the 10th. And remember, the way we simplified it before using our division rule is we subtract it. But then we got what seemed like a kind of weird answer, g to the negative 4th. Well, now we're going to try to unpack what that g to the negative 4th, what it means to raise something to a negative exponent. So we begin by taking our problem and writing it down using our definition. G to the 6th just means g times itself 6 times. G to the 10th just means g times itself 10 times. And then remember the way that we approached this problem before we had our division rule for exponents is we canceled out common factors. So I have 6 of those on the top, and I can cancel that out with 6 of those on the bottom. Now on the top I still have to write something because it's a fraction. So I need something in my numerator. So I write down a 1. And then in the bottom we have g multiplied out 4 times, which is just another name for g to the 4th. And so it turns out here that g to the negative 4th is the same as 1 over g to the 4th. And so in other words, raising something to a negative exponent means dividing by it that many times. So g to the negative 4th means we got to divide by g 4 times, which makes it 1 over g to the 4th. And it turns out this is true in general. There's nothing special about this example we did. Anything raised to a negative exponent will be 1 divided by x to that power. Now there's a second formula that you can sometimes use, but for the problems that we're going to do for the most part, this formula here, x to the minus n equals 1 over x to the n, will be sufficient for all of these problems that we're going to be doing. But there is one other one that can sometimes be useful, and so I want to give that to you just for completeness, and that's 1 over x to the minus n. If the minus power is in the bottom, then it actually means it should just be in the top. So you can always think of the negative exponent as indicating that it's kind of in the wrong spot. It's kind of in the wrong spot. So let's look at some examples here working with negative exponents to just start to get a little feel for how negative exponents work. So our first example here is 3 raised to the negative 2nd power. So being a negative exponent means it needs to move to the bottom, and it would become 1 over 3 squared. Now 3 squared being a positive exponent, we just multiply. 3 times 3 and we get 9. So 3 to the negative 2nd turns out to be 1/9. As another example, let's consider this 24x to the negative 5th. Now I can tell you a real common mistake that I see people make is they'll do something like this. But we actually can't do that. We can't do that. And the reason is that 24 actually has its own exponent. The 24 has its own exponent. There's a measly little tiny 1 there on that 24. Or if something doesn't have an exponent, the exponent's a 1. So the 24 is being raised to the positive 1st power. So the only thing being raised to a negative power is this piece right here, the x to the negative 5th. So when we rewrite this, the only thing that moves is the stuff with the negative exponents. In this case, the x to the 5th. So the 24 stays put. The x to the 5th goes to the bottom. Now if you'd wanted to move both of those, then it would have had to have looked like this. Inside parentheses being raised to the negative 5th. Then both of those pieces would move. Then we'd have to raise both of those pieces to the 5th power in the bottom. But here, since it was just x being raised to the negative power, that's the only piece that moves.